Hello, my name is Laurie Hirsch, and I'm going to be talking about our paper Visualizing Text Co-occurrence Networks, which I wrote together with Simon Andrews, who I'm sure you know. We've produced a new visualization, and I'm hoping there'll be time for you to try that at the end of this talk. But before that, I'm going to briefly go through a little bit of comparison with some other systems, and go through the actual algorithm that helps us build the graphs that we're going to show you. So as a bit of background, a widely quoted figure, 80% of an enterprise data is contained in text format. Often people complain about information overload, and people are looking for ways to help with this problem. One way is summarization. And the use of type clouds or word clouds can be seen as a kind of summarization. We're picking out the important points from a piece of text, we're allowing impression formation, and we get a general idea about what a piece of text is about. We're going to use, for this workshop, we're going to use an example text, which is a recent paper by SOA, and you can open that online if you like and quickly read that. It might help after this talk if you have a look at that text and see the different visualizations that are being built with the same text. So word clouds have been around for quite a while, and they're perhaps the first main visualization that has emerged for visualizing text. They're based on essentially looking at the frequencies of words in a text after stop words have been removed, and changing the size, font, color of the text in relation to the frequency. It should be look nice to the user, should be an attractive way, but also it should help the user get an idea about the main themes occurring in the text. The words are often sorted alphabetically, but there are different ways of arranging the words, and sometimes similar words, there have been attempts to put the similar words together. As an example of here at this website, you can go there and build your own word clouds, and this is the kind of thing that we produce. So from the SOA text, we obviously see conceptual and cognitive and graphs appearing very large. They must be very frequent words in the text, and the arrangement is quite nice, and the colors should go together. And not often these tools allow you to choose different themes and colors and arrangements, etc. Now it's nice if we mentioned about the links between words, so and that's kind of the theme of this workshop. Trees have been presented as an alternative way to clouds, so the format should be more meaningful, and we should get some information about the relationship between words. So I'm going to point you to a site here, and there's a related paper as well that's referenced, and this one allows you to build tree clouds. So this is the kind of thing that can be produced. And we can see that hopefully similar words are appearing together, and they're related by this tree structure. Some words are repeated. You might see that conceptual is appearing in more than one place, and colors are also used to highlight the important words. So you can see obviously some words really do pick out the theme of the article, and some are not so useful, as is typical about pretty much all the systems that are used. Right, our system we call cstiw2016. To be honest, I want to find a better name if anyone can suggest it. I just picked that name because it's kind of sums it up, and there was a domain name available on Google App Engine which I could use because it's fairly unusual. Anyway, the first step is to reduce the number of dimensions. So we've got a fairly large set of stop words that obviously that can be adjusted. All words go into lowercase, so that reduces the dimensions further. We do use stemming, but we preserve the most frequent form of the word. So if we have concepts, conceptual, those two should be condensed to their stem. And if conceptual occurred more times in the text, we'd use that word when presenting on the visualization. So once we've done that, we sort the words by frequency, and the top n words are selected, where n is typically 100 words, but the user can adjust that. So every possible pair among the 100 words is then analyzed, and a graph is selected by a graph is produced by selecting the top n pairs from that list when they're sorted by their co-occurrence value. How do we calculate co-occurrence? So this is different from the sliding window, which is used for the tree clouds and other systems. We use a decaying function. So we do use a sliding window in that we have a maximum distance of 20 words, but the words are given a different value within that window depending on their distance. And the simple formula we use is 0.9 to the power of the word distance. So, and that happens for if we're analyzing a particular pair of words, every time those words occur within 20 words of each other, we add that particular co-occurrence value to the value for that pair. The 0.9 actually could be any value between 0 and 1, and again that can be adjusted by the user on our system. So now we have a list of word pairs, and we have a co-occurrence value for each of the pairs, and we can sort that list of pairs. We can then build a graph by selecting the top n word pairs from the list, and typically that value is set to 100, but that can be adjusted by the user. If we're building a network, then we can use the number of links attached to each node can also indicate the importance of a particular word, and we can change the color and size of that, etc. And this produces a visualization. This is the SOA text using the network visualization on cstiw. And you can see there's a number of undirected graphs. Not everything is necessarily joined. So but again, the most important words, conceptual graph structures, is there at the beginning, and hopefully we can see now the links between the words. So where there is a link between two words, it means they've got a co-occurrence value. More recently, we've been looking at changing the network into a tree format. The graph is the one that we just showed you. Obviously could contain many possible trees, but we use the fact that in our system the words are already in order of their co-occurrence, and we go through, we start the tree with the first pair makes the first link, and then we iterate through the rest of the pairs, but only create a new node if it's preserving a tree structure. So if it's not the case, we'll just simply throw away that particular link. So the tree hopefully has a number of advantages over the network in that the links become kind of clearer. Where there's branches from the label node, it should make the relationship obvious. And it also means that we can now reasonably easily make the tree collapsible. So if the user wants a particular level of detail, they don't need to see the whole tree. It can be collapsed and expanded as they need to. So here's the SOA text in the tree format, and this is using a force-directed layout. So if you click on any of these internal nodes, it will collapse at that point, and then clicking again, it will simply expand. So perhaps this is easier to read than the previous network, and again, the key terms have been highlighted here. How do we build it? Well, we use, at the end of the process, we use the D3 library, a fantastic library for building visualizations, and there's many different, you can go and view the many different forms that can be built using D3. It uses scalable vector graphics, so it should run in any modern browser. The radial tree, we looked at a number of different ones, but with the one that we think is probably the best is based on the Rheingold-Tilford algorithm. And this is what the SOA text looks when we use that one. Because it spaces the words very nicely, and we have the important words towards the center, and hopefully this is picking out some kind of hidden structure from the text. This is one of the main aims of the system. And here's an alternative, which is actually showing this is the graph produced from our paper, and what we're hoping is for the workshop, we want you to actually go through and try some of these, so you can have a look at building a word cloud or the tree cloud, or if you can try cstiw, you can use some of these links here. It'd be nice if I do have a Google Plus page set up, so if there's time, it'd be great if you could post some comments using the link there. And also, if there's time for you to work on your laptops or whatever, there's some detailed workshop. You can either use this slide, or there's some detailed workshop notes on the link number 7 there. Right, well, thank you for listening. Hope the workshop and the conference is going very well, and goodbye.